For most of human history, people believed that the Earth stood motionless at the center of the universe. According to this ancient view, the sun, the moon, and the planets all moved around the Earth in great circles across the sky. The stars formed a distant sphere that slowly rotated every night, carrying the heavens around our world. This idea seemed perfectly natural because from the perspective of someone standing on Earth, it appeared that everything in the sky moved while the ground beneath remained still. For centuries, this Earth-centered model shaped astronomy, philosophy, and even religious thinking across much of Europe and Middle East. Complex systems of circles and mathematical adjustments were created to explain the strange motions of planets, such as Mars, Jupiter, and Saturn. These systems allowed astronomers to predict planetary positions reasonably well. Yet the explanations behind them grew increasingly complicated. The heavens seemed to follow rules that were difficult to understand clearly. In the quiet towns and universities of Renaissance Europe, however, a few scholars began wondering whether the universe might be arranged differently. Among them was a careful and thoughtful thinker named Nicolaus Copernicus, a man whose ideas would eventually transform humanity's understanding of the cosmos. Nicolaus Copernicus was born in 1473 in the city of Taormina, located in the region of Poland that was then part of the Kingdom of Poland within the broader political world of Renaissance Europe. Taormina was a lively trading town along the Vistula River, where merchants, craftsmen, and scholars passed through its streets. The city connected northern European trade routes, bringing together influences from many cultures. Copernicus grew up in a family that valued education and learning. His father was a merchant, but he died when Nicholas was still young. After his father's death, Copernicus and his siblings were raised by their uncle, Lucas Watson-Rode, who later became a bishop in the Catholic Church. His uncle recognized Nicholas's intelligence and ensured that he received a strong education, believing that the young boy could one day serve the church and contribute to scholarly life. As Copernicus grew older, he developed an interest in many different subjects. During the Renaissance period, scholars often studied a wide range of disciplines rather than focusing on a single field. Copernicus learned about mathematics, astronomy, medicine, law, and classical literature. These studies helped him develop the careful reasoning and analytical thinking that would later guide his astronomical ideas. He eventually attended the University of Krakow, one of the most important centers of learning in Central Europe at the time. There he encountered astronomy more seriously for the first time. Students studied the motions of the sun, moon, and planets using mathematical tables and geometric models. These models were largely based on the work of the ancient Greek astronomer Claudius Ptolemy, who had lived more than 1,000 years earlier. Ptolemy's system placed the Earth firmly at the center of the universe. To explain the complicated movements of planets, his model used layers of circular motions called epicycles. In this system, each planet moved along a small circle while also traveling along a larger circle around the Earth. The arrangement worked mathematically, but required many adjustments to match the observations of the sky. Copernicus studied these models carefully. He respected the work of earlier astronomers and recognized the impressive effort they had made to describe the heavens. Yet he also noticed that the system had grown extremely complicated. Each time astronomers discovered a new discrepancy between prediction and observation, they added another small circle or correction to the model. The result was a structure that seemed increasingly difficult to justify. After completing his studies in Krakow, Copernicus traveled to Italy, which at the time was one of the great centers of Renaissance learning. He studied at universities in Bologna, Padua, and Ferrara, learning law, medicine, and astronomy. Italy exposed him to a rich intellectual environment where scholars rediscovered ancient Greek texts and debated new interpretations of science and philosophy. During this time, Copernicus continued studying the motions of the heavens. He observed the night sky, read astronomical writings, and began reflecting on the difficulties within the traditional Earth-centered system. Gradually, an unusual thought began forming in his mind. What if the Earth itself was not the center of the universe? What if instead, the Earth was one of the planets moving around the Sun. This idea was not entirely new. A few ancient Greek thinkers had briefly suggested similar possibilities, but the concept had never been developed into a full mathematical model. Copernicus began wondering whether placing the Sun at the center might simplify the confusing motions of the planets. If the Earth moved around the Sun once each year, then the apparent motion of the Sun across the sky could be explained naturally. If the Earth also rotated slowly on its axis each day, then the daily rising and setting of the stars could be understood as a result of our planet turning rather than the entire universe spinning around us. These ideas were bold and deeply challenging to traditional thinking. Yet Copernicus approached the problem carefully. Rather than announcing his thoughts immediately, he spent many years quietly studying planetary movements and testing whether a sun-centered system could match the observations of the sky. In the quiet rooms where he worked and studied, surrounded by manuscripts, astronomical tables, and mathematical diagrams, Copernicus slowly began building a new model of the universe. It was a model that would eventually change humanity's view of its place in the cosmos. As Nicolaus Copernicus continued developing his ideas about the structure of the universe, he worked slowly and carefully. Unlike some thinkers who quickly published bold claims, Copernicus preferred patience and caution. He understood that challenging the long-accepted Earth-centered model of the cosmos would raise serious questions among scholars and religious authorities. Because of this, he spent many years quietly refining his thoughts before presenting them publicly. After completing his studies in Italy, Copernicus eventually returned to the region of Warmia in northern Poland, where his uncle held an important position within the church. Copernicus himself became a canon of the cathedral in the town of Frombork. This role did not mean he was a priest in the modern sense, but it gave him responsibilities connected to the administration and financial management of church lands. Life in Frombork provided him with stability and the time he needed for study. The cathedral stood on a hill overlooking the Baltic region, and the surrounding countryside was calm and quiet compared to the large cities where he had studied. From this peaceful setting, Copernicus continued observing the heavens and working on his astronomical calculations. His daily responsibilities included managing church property, advising on administrative matters, and occasionally assisting with medical treatment for members of the community. Copernicus had studied medicine during his time in Italy, and people often turned to him for help with illnesses or injuries. Despite these duties, he always returned to his deeper interest in astronomy whenever time allowed. At night, he would observe the sky using simple instruments such as quadrants and astrolabes. These devices allowed him to measure the positions of stars and planets with reasonable accuracy, though they were far less precise than the instruments later astronomers would use. Even so, careful observation combined with mathematical reasoning allowed Copernicus to continue developing his new model of the cosmos. The central idea of his system was simple yet revolutionary. Instead of placing Earth at the center of everything, he placed the Sun near the center of the universe. In this arrangement, the Earth became just one of several planets orbiting the Sun Mercury, and Venus moved closer to the Sun, while Mars, Jupiter, and Saturn traveled along wider paths farther away. This new arrangement immediately explained several long-standing puzzles in astronomy. One of the most confusing features of planetary motion was the strange backward movement known as retrograde motion. When observed from Earth, planets like Mars sometimes appear to slow down, stop, and briefly move backward against the background of stars before continuing forward again. In the traditional Earth-centered model, astronomers explain this behavior by adding complicated layers of circular motions called epicycles. In Copernicus's sun-centered system, however, retrograde motion became much easier to understand. Because Earth itself was moving around the Sun, the apparent motion of other planets could change depending on the relative speeds of their orbits. When Earth passed a slower outer planet, such as Mars, that planet would appear to move backward temporarily from our perspective. The effect was similar to what happens when one moving carriage overtakes another on a road. Another important feature of Copernicus's model was the rotation of Earth on its axis. Instead of imagining that the entire universe spun around the Earth every 24 hours, Copernicus suggested that Earth itself rotated slowly once each day. This rotation explained why the sun, moon, and stars appear to rise in the east and set in the west. These ideas greatly simplified the structure of the cosmos. The movements of the heavens could now be understood through the motions of planets around the sun, combined with the daily rotation of Earth. Although Copernicus still used circular orbits in his calculations, the overall system was more elegant and required fewer adjustments than the older Earth center models. Despite the beauty of this arrangement, Copernicus remained hesitant to publish his work widely. He knew that his ideas challenged centuries of accepted belief. Many scholars were deeply committed to the traditional view that placed Earth at the center of the universe. Changing this perspective meant asking people to rethink humanity's position in the cosmos. For many years, Copernicus shared his ideas only with a small circle of trusted scholars and friends. Around 1514, he prepared a short handwritten summary of his theory, sometimes called the Commentariolus. In this document, he outlined the main principles of his sun-centered system and circulated copies privately among interested astronomers. The response from these early readers was mixed. Some were intrigued by the simplicity of the model, while others were skeptical. Observations at the time were not yet precise enough to prove conclusively whether the Earth moved around the sun or remained at the center. Even so, Copernicus continued refining his work. Over the decades, he expanded his calculations, developing a detailed mathematical description of the planetary system. Page after page of diagrams, numbers, and geometric instructions filled his manuscripts as he worked toward a complete explanation of the cosmos based on the sun-centered model. By the time he reached the later years of his life, Copernicus had nearly finished the book that would contain his revolutionary ideas. That work, when finally published, would introduce a new vision of the universe and begin one of the most important transformations in the history of science. For many years, Nicolaus Copernicus kept his ideas largely private, continuing to refine them quietly while fulfilling his duties in Frombork. His work on astronomy was not carried out in a large university laboratory or observatory, but mostly in the calm environment of the cathedral complex where he lived and worked. From the towers and walls of the cathedral hill, he observed the sky with simple instruments and carefully recorded the positions of celestial bodies. These observations, combined with long hours of calculation and study, slowly shaped the detailed system he had been building. The manuscript that contained his theory grew gradually over time. It included mathematical explanations of planetary motion, geometric diagrams, and careful arguments describing why placing the sun near the center of the universe created a simpler and more logical structure for the cosmos. Copernicus knew that once this work was published, it would challenge one of the most deeply accepted views of the natural world. For centuries, scholars had believed that the Earth occupied the central and unmoving position in the universe. This belief was not only scientific, but also philosophical and cultural. The idea that Earth might instead be moving through space seemed strange and difficult for many people to imagine. If the Earth were truly spinning and traveling around the sun, why did people not feel that motion? Why did objects not fly away from the surface? Questions like these made the concept difficult to accept without strong evidence. Because of these concerns, Copernicus hesitated to publish his work for a long time. He was cautious by nature and preferred to avoid unnecessary controversy. Only a small group of scholars knew the full details of his theory, and even among them the idea was still being discussed and debated. A turning point came when a young mathematician named George Joachim Rheticus visited Copernicus in the 1530s. Rheticus had heard about Copernicus's unusual ideas and traveled to meet him personally. During his stay in Frombork, he studied Copernicus's manuscripts and became deeply impressed by the clarity and logic of the sun-centered system. Rheticus encouraged Copernicus to publish his work so that other scholars could examine it. He believed that the theory was too important to remain hidden in private manuscripts. To help introduce the ideas to the scientific community, Copernicus wrote a short book explaining the basic principles of Copernicus's system. This publication, known as the Narratio Prima, served as an early introduction to the new model of the universe. The positive response to this summary helped persuade Copernicus that his larger work should finally be printed. After decades of study, calculation, and hesitation, he agreed to prepare the manuscript for publication. The book was titled De Revolutionibus Orbium Coelestium, which means on the revolutions of the heavenly spheres. The work was a detailed and carefully constructed explanation of the sun-centered system. In its pages, Copernicus described a universe in which the sun occupied the central position while Earth and the other planets moved around it in circular paths. He explained that Earth rotated once each day, creating the appearance that the stars moved across the sky. He also described how the yearly motion of Earth around the sun explained the changing positions of the planets and the shifting patterns of the constellations over time. Although Copernicus's model still relied on circular orbits and some smaller adjustments, it greatly simplified the overall structure of the cosmos. The complicated layers of epicycles required by the older Earth-centered system became less central, and many puzzling features of planetary motion suddenly made sense. As the book was being prepared for printing in the German city of Nuremberg, Copernicus was already elderly and in declining health. Years of work had finally brought his ideas into a form that could be shared with the world, but the long process of printing and distributing the book meant that he would see little of the reaction it would generate. In 1543, the first printed copies of the Revolutionibus were completed. According to later accounts, a copy of the book reached Copernicus shortly before his death. The man who had spent decades carefully constructing a new vision of the universe was able to see his work published at the very end of his life. At the time, the book did not immediately transform astronomy. Many scholars initially treated the sun-centered system as a useful mathematical model rather than a literal description of reality. Observational tools were still limited, and the evidence required to prove Earth's motion would only emerge later with improved instruments and further discoveries. Yet the ideas contained within Copernicus's book had quietly introduced a new way of thinking about the cosmos. By placing the sun at the center and allowing Earth to become a moving planet, Copernicus had begun a transformation in humanity's understanding of the universe. His work opened the path for future astronomers who would continue exploring the structure of the heavens with greater precision and deeper insight. After the publication of De Revolutionibus Orbium Coelestium in 1543, the ideas of Nicolaus Copernicus slowly began spreading through the intellectual world of Europe. The book itself was written in careful mathematical language and intended mainly for astronomers and scholars who were familiar with the complex calculations used to study the heavens. Because of this, its influence at first moved quietly through universities and scientific circles rather than immediately changing public understanding of the universe. Many astronomers initially approached Copernicus's system cautiously. The idea that Earth moved around the sun was extremely different from the long-established belief that Earth stood motionless at the center of the cosmos. For centuries, this central position had shaped how people imagined their place in the universe. Accepting the motion of Earth meant accepting a profound shift in perspective. Even among scientists, the Copernican model raised difficult questions. If Earth was traveling through space at great speed, why did people not feel that motion? Why did objects thrown into the air fall straight down rather than landing far away? Without a full understanding of physics, these questions were challenging to answer. As a result, some scholars treated the Copernican system mainly as a convenient mathematical tool for calculating planetary positions rather than as a true description of reality. Yet the clarity and elegance of the sun-centered arrangement continued to attract attention. One of the astronomers who studied Copernicus's ideas carefully was the Danish observer Tycho Brahe. Tycho carried out some of the most precise measurements of planetary positions ever made before the invention of the telescope. Although he did not fully accept the moving Earth proposed by Copernicus, his detailed observations later became the foundation for the work of another astronomer, Johannes Kepler. Kepler used Tycho Brahe's data to analyze planetary motion with extraordinary care. Through years of calculations, he eventually discovered that planets move in elliptical orbits around the Sun, and that their speeds change as they travel along those paths. These discoveries, known today as Kepler's laws of planetary motion, confirmed the central idea that the planets revolve around the Sun rather than around the Earth. Soon after Kepler's work, another scientist added powerful new evidence in support of the Copernican model. In the early 17th century, the Italian astronomer Galileo Galilei began using a telescope to observe the heavens. The telescope allowed him to see details that had never been visible before. Galileo observed mountains and craters on the surface of the moon, showing that the moon was not a perfectly smooth celestial sphere as many philosophers had once believed. He also discovered 4 large moons orbiting the planet Jupiter. This observation was especially important because it demonstrated that not everything in the universe revolved around Earth. There were clearly smaller systems in which objects orbited other bodies. Galileo also observed the phases of Venus, noticing that the planet appeared to change shape in a way similar to the moon. These phases could be explained naturally if Venus orbited the Sun. In the older Earth-centered system, the phases of Venus were much harder to explain. Together, these discoveries gradually strengthened the case for the Sun-centered universe first proposed by Copernicus. Later in the 17th century, Isaac Newton provided the final piece of understanding by developing the theory of gravity. Newton showed that every object in the universe attracts every other object through a force that depends on their masses and the distance between them. Using this idea, he explained why planets move in orbits around the Sun and why the motions described by Kepler occur exactly as they do. With Newton's work, the structure of the solar system became clear. The Sun's gravity holds the planets in their paths, and the Earth is simply one member of this larger system moving through space. When Copernicus first imagined a sun-centered universe, he could not yet explain the physical forces behind planetary motion. His achievement was recognizing that placing the Sun at the center created a simpler and more coherent picture of the cosmos. By rearranging the structure of the universe in this way, he opened the door for the discoveries that followed. Nicolaus Copernicus died in 1543 at the age of 70, the same year his great book was published. During his lifetime, he lived quietly as a scholar, administrator, and physician, rarely seeking attention for his ideas. Yet the model he developed eventually transformed astronomy and reshaped humanity's understanding of its place in the universe. Before Copernicus, most people believed that Earth stood at the center of everything, surrounded by the rotating heavens. After Copernicus and the scientists who built upon his work, it became clear that Earth is a planet orbiting an ordinary star within a vast and expanding cosmos. Today, the Copernican revolution is remembered as one of the most important turning points in the history of science. It marked the moment when humanity began to understand that our world is part of a much larger system governed by natural laws. The quiet calculations of a careful astronomer working centuries ago helped shift the human perspective from a small, Earth-centered universe to the immense and dynamic cosmos we continue exploring today.